This is going to be the 6.1 video for alternative example number 1. To get to the alternative examples, look in Chapter 6 folder, 6.1 alternative examples blank, and I'm also going to be talking off the solutions as well as the formula sheet. In the 6.1 blank, if we look at number 1, it says that in 2010 there were, well, you can pause the video and you can just read it to yourself, and then you can press play after you've done reading it. Okay, now that you've read it, Part A is a review of what we've done last chapter. It says show that the probability distribution for X is legitimate. Now X is the number of goals scored by a randomly selected team in a randomly selected game in the NHL. And so X can take on either a 0 goals, 1 goal, 2 goal, 3 goal, 4 goal, 5 goals, 6 goals. And these are the likelihoods, the probabilities of a randomly selected team from a randomly selected game scoring one of those things. So like the Blackhawks scoring 3 goals would be 22.9%, something like that. So to show that it's legitimate, obviously we can just add up all these and it should equal 1, and it actually does. So I'm going to save you the trouble of doing all that calculating. Part B says to make a histogram of the probability distribution and describe what you see. So to do that, you're going to put probability on the y-axis, and we're going to put x on the x-axis, and we're going to label that goals. And when you actually graph that, I'm just going to show what it looks like. This is what the graph ends up looking like. And what we have here is there's a peak at 2. 2 and 3 are roughly the same. So there's a peak here at about 2 or 3, and this graph seems to be skewed to the right because it is very unlikely to score that many goals, 7, 8, 9 goals in a game. So that's why the distribution is skewed to the right, and it's much more typical to be getting 1, 2, 3, 4 goals per game. So that's what I would describe that I see. Then in part C it says, what is the probability that the number of goals scored by a randomly selected team in a randomly selected game is at least 6? So to be at least 6, we're talking equal to 6, or like 7 goals is at least 6, so is 8, so is 9. So the probability, we can calculate it at least 6 just by adding up these probabilities here, but I want to go over the notation on how the notation works in 6.1. So this is how we would show the probability of X, the number of goals scored by a randomly selected team. That entire phrase right there is summed up by this variable X. X to be greater than or equal to 6, we would just add up the 6, the 7, the 8, the 9, and then we get 61%. Or you could have just done 1 minus the complement, which is everything less than that. If you're wondering whether you could just show it this way, that's another way to show at least 6. At least 6 is any number greater than 5. So you could have shown greater than or equal to 6, or simply greater than 5. For the last part, I'm going to show a trick on the calculator. Part D says compute the mean of the random variable x and interpret the value in context. Now the mean of a random variable x is just a weighted average, just like in your math class where your final exam is worth 20% of your grade, your test is worth this percent. To find your weighted average, you would multiply what you have in the class in each category by the probability of each of them. And that's shown here on the formula sheet, on the second page of the formula sheet, right here. This is the expected value calculation, and I'll be using mu x in my notes. This is the sum of all of the products of the outcomes times the probability. So let's see what that looks like in this problem. So in this case, to get the average, what we would do is we'd multiply, what we would do is multiply 0 times its probability. So the probability of getting 0 goals is 0.61. The probability of getting 1 goal is that. So we're just summing, we're doing the sum, adding up all of the outcomes times its probability, and when you're done, you should get 2.851. And what does that mean, 2.851 goals? Now, I know you can't score 2.851 goals in NHL hockey, but you'll have to ignore that, and you'll have to just think to yourself, what does this actually mean? And what this means is that after many times of picking a randomly selected team from a randomly selected game, the average number of goals scored is about 2.851 goals. Now, if you don't want to type this whole massive thing into your calculator, there is a shortcut on the calculator that I'll show you right here. Here, in my calculator, I'm going to go to Stat, Edit, and if you look here, I've got my goals in list 1, and I've got the probabilities in list 2. And what we could do here is we could hit Stat, go over to Calculate, and do one variable stats. And we've done this earlier in the year, but this time, list 1 is the number of goals, list 2 is the frequency. How often do those goals happen? That's in list 2. So you put it in that way, and you hit calculate, and there is our average number of goals, 2.851. By the way, later on in this section, you'll also be doing standard deviation calculation, and it'll look really long to write. But instead, after you write out this big massive equation, you can just use your calculator, and it will do all the calculating for you.